we know that there's a lot of deep learning models implemented in the automation industry, especially the self-driving cars. So those are just but to mention a few of the areas of applications that machine learning in general can be used or implemented. Dr. Joab, I think that's our last slide for the introductory part of it, and we are excited to delve deep and learn more as we continue into getting to see how AI, data science, artificial intelligence, and machine learning can be implemented in various aspects of our lives. Thank you. Back to you, the moderator.
Thank you so much, Dr. Joab and Jasper. That was quite an elaborate session. I believe I picked up quite some points, and I believe all our all attendants also did the same. Yeah. So I think the optimization bit, getting the best decision based on some patterns in the data for your problem, be it financial. Yeah. So I think that is quite eye-opening, and also you are very keen to tell us the intersection of data science and mathematics, that probably we need to know a little bit of linear algebra, a little bit of calculus. Yeah, so that was so insightful, and I believe those who are starting out in this field or have interest in the field, they already know where to look or where to start. So that's quite an informative session. So thank you so much. Again, I want to remind everyone that you can post your question on the chat. There is actually a Q&A section where Adrian has indicated that you can post our comments and even our questions. Great. I think we move to the next topic, not really a topic, to the next section for our open forum, which is NLP, natural language processing. It has been mentioned already by Dr. Joab and team. They have already told us one application of deep learning, where you have those artificial neural networks, but with more layers. So they have said already that we can. It's being used in NLP, so natural language processing. So I believe I should invite Colleen to tell us more about what is this NLP. It's been a buzzword of late. What does it mean, probably, and how is it being applied in the daily life of non-technical aspect of the population? There are those people who don't know much about coding and programming and maths, but they are using probably NLP daily. So those application areas in our daily lives, I believe we could hear what Colleen has to say. So, Colleen, if you can hear me, the mic is yours.
Thank you so much. NLP is a rapidly developing field these days. It's a set of tools to work with text data. So a lot of machine learning algorithms need a certain format for the linear algebra to work, and text data doesn't really work with those formats. So we have a lot of tools to break down text, to embed text in matrices, and to really just wrangle it into something that we can use statistics and machine learning on. You're probably familiar with leaving feedback for products, so product reviews on Amazon and other platforms. It's used a lot in education, in the medical field, so doctors' notes can be analyzed to look at patient outcomes and diagnoses. Within the legal field, a lot of cases are being summarized using NLP, and chatbots are another huge part of NLP. So language generation has really exploded since GPT, and large language models. There are a lot of open source ones on Hugging Face. So anyone who's interested in this, I would encourage you to look at Hugging Face, as they have open source models for embedding text, for generating text, and in general, working with text data. Python also has a great package, actually a couple of great packages. So there's Spacey and there's NLTK, both of which have great tools for analyzing different aspects of text and really working with that data to be able to extract information and be able to put that into machine learning models. One of the big challenges is data integration today. So a lot of data that companies have and nonprofits have and universities have is data that's in text form and image form and in the relational databases that are a bit more familiar, and being able to extract meaning from these different sources allows us to combine insights from text data, from image data, from relational data, from survey data, and combine them into a single model.
Wonderful. That's so insightful, Colleen. And I believe also open source sites like Hugging Face have a lot of materials for learning and use for this field. And I also believe GitHub sites, some contain a lot of tools, a lot of information for learning. Yeah, I believe that was a great insight into NLP and all that. I wanted to hear from maybe Colleen and any other panelists, what is their contribution in nowadays. There is the issue of building these models from on top of or using transformer models. So like you don't have to start doing the bit about breaking the text and bending the text from scratch. You can use ready-made transformers. So how are they changing the landscape of NLP? Maybe Colleen, your thoughts?
Okay. I'll start, I guess. So one of the things that I've been working on lately is looking at the quality of embeddings for different use cases, looking at the models on Hugging Face. And I've found that training samples matter a lot. So I've gotten very different performance from different embeddings. And this has to do with the data collected. And it's kind of the Wild West right now. We don't know a lot about the quality of the data, and it's sometimes wise to try a lot of different open source models to figure out what works best with your use case. One thing that can be done is fine tuning. So if you have a language generation platform, you can upload your own data or find open source data that matches your use case and modify the neural network behind this tool using your own data, which often gives a lot better performance than the general model. So it's a tricky time to really find the right model that's going to give you good performance on your use case. A lot of these are very general, and the modification or finding one where the training data is a good match to your data set is going to be really important if you're using these tools in practice.
Okay, great. That is quite good. The quality of data is very important in this case, because you are fine tuning. You are trying to apply a different use case to your new case, which could be hampered by the quality of data. So I think that those are good insights and comments. So I want to ask whether we have any contribution from the panelists before we move on to our next item. be free to just unmute and talk or post your comments. And if also we have questions from the audience, please be free to post your question. Maybe there's something you've been hearing, you don't understand what it is in natural language processing. I think you've heard of text generation, like the Chat GPT that is helping us generate text. I think Colleen also talked about summarization. NLP is being used for text summarization, especially in quotes. Yeah, so if you have any clarification you would wish to get, I think this is the right time to post in the chat or just say it.
Yes, thank you very much. I have something else in mind. I've seen Jabba is unmuted. Let me just go. So most of us do interact with NLP models quite often. So somebody, let's say you're using something like Google Assistant, if you have something like Siri, if you're using an iPhone. So some of these products are already out here in the market. We interact with them quite often. It's only that they're not like labeled, that this is an NLP. So most of the time we are already with them out here. Then anytime you're using, let's say, a language translator, you go somewhere, you don't understand the language, you're speaking English, you're speaking maybe to a German, and you need this person to understand. So such tools are already in existence. So sometimes what you can do is just go out there, test them out. The more you consume them, the more interest you're going to develop in trying to understand how do they work, what were they built on. Yeah, and that's it. I saw Joab had unmuted himself. Joab, mic is on you.
Thank you very much. Maybe I think most of the things I wanted to say have been said, but however, maybe just to add, when you're coming up with these NP systems, NLP solutions, whether do you do it from scratch or when do you use from transformer models, sometimes it's good to look at the pros and cons of each of the solutions that you want to, options that you want to use. Whether you want to build from scratch, look at what are the pros that will come from it. Some of the pros, maybe if there's data efficiency, domain customization. Also, you need to look at the cons that comes with that options. Maybe do you have expertise that is needed, or are they resource intensive when you want to build? Of course, when you're using now the transformer models that exist, there are also pros that comes, because when you choose that options, you have to do like pre-training, you have to train these models, and they will give you much better performance, and some of the advantages also like times and resource savings. However, they also come up with some cons that you have to understand, whether they will give you some genetic, what we call genetic representations, because they are not able to do exactly what you want to do with them. And so that some of this, ideally, you have to balance between these pros and cons of the two options that you choose when you're making that decision. So it was just an addition I wanted to add to what has been said by a colleague. Back to you. Thank you.
Thank you. Thank you, everyone, for their contribution. I think there's a good question on the Q&A section, but we'll hold that question. It's talk about whether you can share your opinion on use of large language models, LLMs, such as ChatGPT, with regard to data privacy. But I think we'll discuss that under AI regulation, which is another open discussion that we are going into in a few. So I want us to move to the next area of our discussion today, graph or network science. This is an area that could be a little new to our audience, but we felt that we needed it in our discussion because it's currently very crucial to understand it, and we also want to hear how is data science coming in and contributing to this field. we want to know, like, are there any real life examples that we are using these network science without maybe our knowledge? Like how is it being applied in real life, and how is it impacting our lives? So I think for this one, we task Colleen again. Sorry, today, Colleen, you have to speak a lot, but I believe you could give us an overview. What is this network science, and does it involve data science? Are we using it every day in our lives? Yeah, what is it? So please, again, I welcome you, Colleen.
Thanks so much. So yeah, network science is really everywhere these days. If we think about social media, you probably have friend suggestions on social media. You're interacting with content and getting recommendations for products, for people, for posts. All of that depends on network science. Basically, within network science, we're defining a set of something, whether that's people on a social network or products that are offered on a platform, and the relationships that exist between them. One of the more current applications, I think, is contact tracing within epidemics. So looking at the spread across cities, between people, all of these things can be tracked with network science, looking at relationships, looking at probabilities of infection across a network, can really help apportion resources to respond to an epidemic like COVID-19 or Ebola or whatever the next emerging threat is. And this is really important. Another thing that we can look at is behavior or viral trends that are spreading through a population. These might be good, so fitness or nutrition trends that are spreading, or it could be harmful behaviors that are spreading among adolescent populations on a social media platform. And there's a huge interplay between data science and network science. A lot of the tools can be translated between one or the other. And sometimes the algorithms are a lot more efficient taking a network perspective on the data versus some of the more traditional tools. And we'll see this in my later talk when we look at spatiotemporal data, so geography and time-based data within climate change. We get a lot of computational gain and can scale our models a lot better using network science tools than a lot of those statistical algorithms that exist.
Great. Thank you so much. That was so insightful. I want to welcome questions from our audience on this area. Actually, so many people are thinking network science is so different from data science, but after your elaboration, at least you're able to. We remember during COVID-19 how we used to track the contact tracing and how the Ministry of Health here in our country was doing the whole thing. I want to believe they were working with network science, or they were applying network science and probably some data science approaches. And yeah, thank you for clearing the air, Colleen. So I can't see any questions from the members. Dr. Joab, do you have any comments on this area or contribution? Or maybe Jasper? I'm not sure whether Sharon is in. Could also hear their contribution or questions, probably. Okay, thank you. So I believe there are no, at the moment, any comments or questions. And I believe, as Colleen has promised, she's going to talk more about it when she handles the climate change and application of data science. Yeah, so let's wait until that time. Okay. Now, our last session for this open discussion is AI regulation. we know that AI is currently trendy, and people have fears about it. People fear so many things about AI. It will take their job. Education is fear that exams nowadays, or maybe assignments or homeworks are being done using chat GPT, generative AIs, and such kind. So there's a whole debate about how should it be regulated, and yeah. So this is our next discussion, and we'll start with the key aspect shaping the AI regulatory landscape. What are the challenges? What are the issues that we have that are making people think now this is the time now we start regulating AI? Yeah, so Sharon, are you here? I wanted to have you start us off in this. If not,
Yes.
Titus. Okay, go
Yes.
ahead.
Thank you. Thank you very much, Julius. Give me a
All
few
right.
seconds. I share my screen.
Yeah. All right.
Can you see my screen?
Yes, we can, Titus. Go ahead.
Okay, fantastic. Thank you very much. Sharon, can you try unmuting yourself? Yeah, give me a few minutes or seconds. Let me just get a hold of Sharon.
Hello?
Yes,
Hello?
we can hear you now. We can hear you.
Could anyone just confirm for me audible?
You are audible.
Yes, you are. Yes.
Thank you. Thank you. Okay, sorry. So sorry. I've had a lot of problems this first hour of the session, but hopefully this next hour will be a bit smoother. So before I
You are muted, Sharon, if you are speaking.
sorry, I'm sure by now you've already discussed what artificial intelligence is and those key aspects that are involved in
Hello. Let me see what's happening with Sharon. Give me a few seconds.
All right. All right. Yeah, AI regulation is quite in its early stages. The landscape is constantly evolving. It's at infancy. We had Elon Musk, one of the richest guys in the world, the other day. His views about AI regulation. He warned that AI could maybe cause civilization destruction and such kind of bad things, and that it was one of the biggest threats to humanity. So he was campaigning for a transparent AI, explainable AI, and AI which is accountable. So there are these concerns from some of the best brains we have in the world and richest guys. Yeah, about it's a great. It brings opportunities as well as threats. So that's why the whole concept of regulating it. Yeah, as we wait for Titus and team to finalize.
Yes.
Okay, you are
Yes.
set.
Thank you. Thank you. Yes, she's here.
Good. Go ahead. Good.
Sharon, we can see you are talking, but we cannot hear you. Before we were
Okay,
hearing you,
okay.
now you listen. Oh, now,
Can you
yes,
hear
now
me
you're
now?
good. Yes.
Okay. Could you move to the first slide? Let's just start with the slides. Okay, so
Titus, you can try
first of all,
presentation mode, probably.
okay, as Titus sets it up, I hope you can still hear me.
Yes.
Maybe I could just start.
Yeah, just go ahead.
So first of all, the need for regulation. Why would we want AI to be regulated? So in the recent past, we've been noticing a number of things that have of harmful events that have risen up due to AI. You can already see the small signs that AI may pose a huge problem in the future. For example, to give a very recent example is in the war between Israel and Palestine. Uh, there's this whole issue around a photograph going around that was being proposed that it had been created by AI. So that already that effect of being able to put propaganda out because of how well it can be able to mimic the real thing is already an issue that's being seen as we go forward. And aside from that, we've also had cases where it's, for example, in the UK, there were some fraudsters who tried to trick a particular company by using AI to mimic the voice.
Sharon, I don't know if people can hear you, but I lost you on my side.
Yeah, I also can't hear.
Hello, Sharon. Can you try maybe switching on and off your network? I'm not so sure what's happening. Yes, I think I will just take over. It seems like Sharon is not available as much as at the moment. Yeah, so what she was saying was that as technology advances, we're finding people using AI in ways that they're not meant to. So these tend to be more or less bad actors. Bad actors is these are persons who will exist in each and every single technology that is out there. So you can create a product for good, but somebody else will take advantage of it. So Sharon, in case, oh, give me a second. Give me a second.
Hello? Can you hear me?
We can now hear you, Sharon. Please go ahead.
Okay. I think to save on time, perhaps someone could help me do the presentation titles. If you could just read through the bullet points, because it's not necessarily something that has to be outside the bullet points. I can stay within the presentation so that I can add where I think I needed to add on a slide or something. But this idea of me popping out of the meeting, I think it's wasting quite a bit of time. Would that be acceptable?
Yes, no worries at all. I'm going to go through your presentation. I believe people can see my screen. Yes, so what I was explaining is that sometimes you can create a technology for good, but bad actors or persons who just want to use it for other purposes step in. And it has been used to sometimes interfere with geopolitical matters, as we saw what was being explained by Sharon as she was talking about the Israel-Hamas war, and not just that, but also sometimes when people want to mimic, let's say, a president. Let's say there is somebody called President Hammond, and people want to be like him. So deepfake is something that is real, and people are using it to impersonate other people. So when it comes to, yes, the one for mimicking the CEO's voice, yeah, that's something that has happened not just in 2019. It also happened sometime, or is it like this month or last month, whereby somebody comes in, tries to mimic somebody else's voice, and are able to withdraw quite a chunk of money. Yeah, so such matters resort to the need of AI to be regulated. So what are the steps that have been taken to regulate AI so far? So we already know that various countries around the globe have been working heavily towards this. So in this case, we have countries like South Africa, Nigeria, Kenya, Ghana, Tunisia, Egypt, and Rwanda, just around Africa. We know that the EU was leading into AI regulation around the world. Yeah, so there is some global framework for AI regulation that is being set up. As if you follow some international news, the moment we saw by stepping into the fields, there was the need that raised. People are using AI for means that they're not meant to. And as a result, we saw that Canada and France back in 2018, they launched some kind of partnership to be able to come up with some very early use or regulations around artificial intelligence. Yeah, so the EU has been a front runner in coming up with various formulation, and this has greatly contributed to the success of ethical consumption of AI tools. As you move forward, so are they able to come up with these regulations? So when it comes to data that is being used to feed into these algorithms, so we know garbage in, and it is very important to come up with ways to regulate the kind of data that is being consumed with some of these AI tools. So in this case, we can have matters such as maybe privacy issues that can come up. In this case, let's say this is a chatbot, and this chatbot requires some of your personal information. So it already has your voice because maybe it's a natural language processing algorithm. It already knows your voice. It knows some of them even ask for things like your location. If this is an app that is using it, they have access to some various features or um, maybe other apps in your phone. And as a result, privacy becomes a very big issue. Fairness, it is obvious that the data we feed most of the AIs that are out here tend to be biased in terms of who is this person consuming it, what's our target market. So if it's a tool that is built for the African target market, you try using it in, let's say, states, you realize that it does not work as efficiently because it is not meant for a specific market. Transparency is a very big concern. Most of us use different kind of AI tools and we expose them to a lot of personal information. But then at the end of the day, you don't know where this data is being stored. You don't know who's using it. An example is, do you have access to ChatGPT's data sets? I don't know if there's somebody who has access to them. So all this data that it has collected over the internet, let it be company kind of data, maybe some description, you name it. You're not too sure who is the person cleaning this data, who's the one handling it, how is it being saved, is it safe? So transparency is another matter. Already talked about safety. So is the AI space safe? Some of the content, like I remember early back in the days, there was this chatbot I was testing out on Twitter back when it was Twitter. So when it came up, it was a very big deal. Like all over high school, everybody was talking about it. I'm like, what are these people talking about? Though I cannot even remember its name. So when it started off, it was quite interesting interacting with it, asking it questions like it was some sort of a conversation. Then all of a sudden, it became something else. It became violent. It became very insultive. In short, they just had to pull it off. It was not safe being there because the kind of language it was learning, the kind of data it was being fed, it made it at first it was safe and fun, but later on it was not. So that's where some sort of human control must come in and ensure that whatever is being fed, the data is being fed, it's what is relevant. But the problem is this is a tool that learns. Despite it, you training it with a specific set of data, if it goes out there and people are using it on a daily, it starts learning and relearning. So eventually you realize what you built to serve a specific purpose. Maybe it's for good. Later on, it just starts, going haywire. Yes. So when we're talking about manufacturers, I saw something that happened whereby an AI tool actually caused an accident in a factory, and this employee died in a very gruesome way. So in this case, who takes responsibility? So we have seen regulations trying to understand. Let's say somebody created an AI. Let's say Fidel created this tool that packages boxes inside a factory. But by mistake, somebody on that day ends up being identified as a box. I don't know how, but somehow it happens. And this machine decides to pick this person up like a box. And as it picks this person up, it decides, okay, this person, I'm going to store him somewhere. And it decides, I'm going to package you here. Maybe this is a spot where you look like you belong. So in this case, when that happens, who is at fault? Is it the company that built the algorithm? Is it the company that bought this algorithm and used it? So in this case, we're looking at third-party integration. So who is at fault in this case? So looking at something else around human values, we are trying to understand if AI is something that understands human values. But in this case, I do not think it's something that can be easily done. Oh yes. Sharon, I've seen that you want to chip in. Sharon, you can chip in. Oh, maybe not at the moment. Yeah, so let us continue. So, respect for human values, we are still very, very far from this. I believe quantum computing is the next phase that will make AI evolve. In short, how can AI move from one step to another? How can it learn, relearn, and try to mimic human behavior interaction as smart as possible? So the EU AI Act, I will not go through that. I believe Sharon had already did her research around it, so she would have been best to contribute for this. But let me just go through it. So this is something that came up around June 2023, and it tries to classify the level of risk proposed by AI. So unacceptable risk, high risk, generative risk. Give me a few seconds. I check this out. I believe Sharon is trying to contact me. Oh, interesting. So, okay, thank you very much. I will give you the opportunity as this session goes. We're almost done. Then you can come in and chip in. So, the EU Act of 2023, I'd like to recommend each one of you to go and read it through. I have already gone through it briefly, but I can say that the EU is becoming a front runner in coming up with AI policies. And what this means is this: as we know it, most regulation around the world is usually a copy and paste. A copy and paste of what works where and how. Copy that, paste it on your end, and just do a little bit of editing to suit your use cases or your consumers. So around the EU Act, I will not be able to go through it as much. But in this case, maybe Sharon later on, if she's ready, she can come in and chip in around it. Yes. Oh yeah, we have already talked about it around safety and fairness. So in this case, when it tries to mimic various kind of behaviors, what we have seen is something that is becoming quite dangerous, and we're seeing a lot of children being exposed to various AI tools, and these tools can actually be at a huge risk. An example is during various interaction with maybe games they play and all that. I hope you guys can see my slides moving. Yes, I can see, but if I put it in presenter mode, it doesn't move. I don't know why. It moves on my side, but it doesn't move on your side.
Okay, you could take us back to the normal mode then, so that we go fast.
Okay, fantastic. Let me just give it. It's already in presenter mode. Is it showing different on your end?
Oh, I currently can't see your screen.
Okay, give me a few.
Try sharing.
I am. Give me a few seconds. Yeah, there it is. So let's move a bit faster because of time. So when it comes to the regulatory side about it, this is
Sorry,
something that will be
moderators.
handled. Yeah.
Maybe let me take us through this. I think the last half of the document. I think I can be able to at least a bit faster now.
Yes. Yes.
Okay, so yeah, where you've started at is the EU AI Act. There was an act that was proposed by EU in June 2013, and it was not necessarily a new one. It was a follow-up on an act that had been presented earlier in 2021. So that the way that this act sought to regulate the AI was to classify it into 4 main risk categories: the unacceptable, the high, the generative, and the limited. So where you are at the presentation is the unacceptable. And if you notice, the unacceptable risk are, sorry, just go to the unacceptable. They are AIs whose work is too unsafe to be regulated. So essentially, they would have to be stopped. There are some exceptions. If you go look for the document, I think you'll find some exceptions. But on a general level, these are too risky so that to be placed, to be ideally left out. So this is the unacceptable ones. And these are particularly the ones that are dealing with safety issues. For example, the example given there was a cognitive behavioral manipulation of people or specific vulnerable groups, for example, children. An AI that suggests to, for example, someone who's looking for a suicide hotline and calls in an AI that suggests, that gives information that may lead to them, to supporting them do suicide than not, falls into this level of unacceptable risk, so to speak. Then the second bracket, go to the next slide, where of the next level of risk was the high risk. These are now where they are very risky, but it's possible to regulate. And one of the main things the EU Act proposes for these ones is particular registration, and then follow up on even assessing the follow up on the AI as it's being deployed and even throughout its deployment. So this is where regulation will be built even more for particularly AIs that fall into this. And I would suspect most AI models will tend to fall into this risk. Then the last two, the generative AI and the limited risk, are where the key ideas that the regulation proposes is about transparency. For example, ChatGPT would fall under generative AI that generates content. So the question is, can we be able to be transparent about that this information came from an AI, and also transparent about the data that allowed for us to produce this? So, for example, the issue of I think I saw someone in the chat, if a student uses AI and then writing the assignment that this AI was what was used to generate this data, would that be acceptable? Now, if this goes into regulation, it's sort of to say that all generative AI content must at least have a way to be shown that this can be traced to the generative AI. It will really help with things, especially things to do with fake news and propaganda, because then now you can always drill down to where it was. I think, but that's just a personal opinion on the idea. So just move on to the next slide, and that's generally basically what the EU Act was about. It wasn't an act that goes into the details of the rules of how we regulate, but it's building a huge framework, an outline for where all these rules will now be developed from. More than that, in America, they've also been tracking with regulating AI from quite a while back. When I was doing my research, I noticed it's around in 2016, one of the first acts was being proposed, but we need to look at this AI thing. And the most recent one is the one I've included here, is Biden's executive order. It was just released recently, last month in October, where once more, it's not the exact rules that we need for regulation, how you'd think regulation is, rather it's a bucket for what the regulation will entail. And even as the order was being given, we've been told that it's going to be developed as time moves forward. So it was just outlining specific key things that will be looked at when we are going to regulate AI moving on forward. So you'd see something about registration of AI models was in the executive order, where it's going to be a requirement for you to be an AI, you need to have registered, and the reporting how they would need to be carried about. It left a lot of blank on some areas. For example, how to handle open source AI, will they be same as models? But at least the target it also had was on focusing on large models. I think part of the reason the executive came about, if you read the executive order itself, it's one of the first key things they mentioned is this came about in order to make sure AI doesn't necessarily do something to necessarily drastically affect the government functions. Sort of it's very targeted on AI trying to cross boundaries and affect beyond in a way where the government may be affected, so to speak. I don't know if I'm coming out very clearly, but it was just that it was an order. It's a small page order, around 52 pages, but most of it is an appendix, but it just gives you the bucket of what AI regulation will be. So maybe move on to the next slide, Titus. So before I go to the public perception of AI, you can notice that AI regulation, I don't think there's a country that has the exact rules like this is exactly how we'll pin down AI, but countries are seeing the importance of it and they are forming big brackets of how we'll form the AI regulations. What you will find in countries is, for example, because AI crosses board with very many other sectors, for example, it may cross board with the food and drugs sector, so you'll find that there is a regulation within the FDA food and drug sector, for example, in America, that has some small effect on AI, but it's not necessarily a regulation. AI doesn't have its own regulation set out, but it is the countries are working to set out those to set out regulations that are going to be purely for AI, especially because there's a lot going on in the AI environment. So publicly, the people, when people are asked about the importance of AI, I think people's biggest fear with AI right now is that it may take our jobs. It may, we've seen movies like robots overtaking the world and all that. They may go rogue and affect things negatively. I think so. Because of that, people haven't necessarily embraced AI, so to speak. We have embraced AI at the smaller level, because I think things to do like ChatGPT and the small models that we use them in our daily life as much as we don't associate them with the big risk for AI. So even the statistics I had just put in the previous slide, this I think would be the common person who would think when you tell them AI, they would think a robot. In their minds, they think a robot. So even when we talk about regulation, you find that not most of them have that much interest. Or if you notice the statistics here, unfortunately, the statistics I found here were found from Wikipedia, mostly to do with Chinese citizens and American citizens. You'll find that there's a lot of the Americans don't necessarily embrace AI as well, and I think such chances are it may be just that scary bit of moving into new technology. What does this mean, and the changes it's going to take for us? So even when we come to asking them, do you think AI regulation is important? I think because we already have a certain view of what AI is, we don't. People may not necessarily give that much close attention to that. We need to regulate this thing because it's coming or it's going. So I think that's how I would summarize the public perception of how people think about AI right now. So the potential impact of regulation on innovation. So again, if you involve government in things like AI, there's a chance that there's going to be some big drawbacks. For example, AI as it is, it's blowing up, but I think it has a lot. I think everybody knows AI has a lot of potential to do so much more. And the problem with regulation is sometimes you have to set rules that people must adhere to, where it would have been better perhaps to give them just a little bit of freedom so that they can be able to make those mistakes they need to make and then make the product better. But when you set in place rules that must be adhered to, I feel like you'll end up kind of blocking some areas that could have been able to make it thrive even more. However, the way the regulation process is moving so far, I think is very favorable for the AI sector, because as it is, it's like the regulation is moving in pace with the AI. So we've not yet had those strict rules, but we have a road to that, and hopefully that road keeps in track, so that as the AI is growing, the regulation is getting a bit stiffening, so that to get to a place where we have a way to regulate it, because we also don't want a place where there is no regulation. If you end up in a place where there is no regulation, then we'll start having monopolies in that kind of situation. We'll start having things that affect countries and the world in very drastically terrible ways. So it's important that the regulation catches up with AI even as it's going on. And another also drawback that you may have with regulation is you need to be careful so that regulation also doesn't end up causing more harm than good in the long run. Example, I think one example is AT&T, the company, telephone company, an American telephone company. It owned the market, the telephone market, for around 60 years before the government saw that it's a problem and they needed to break that monopoly. It had to be broken. And part of the reason it owned the market so much is because it was patenting issues and stopping other companies from coming in quickly. It was taking advantage of the regulations set in place to be able to make itself a bigger player. and it may not work necessarily that way for AI, but you may find that sometimes regulation can end up promoting something that we've not yet thought about, and then it ends up being a drawback. So even as regulation is being made, I think it's also important to pay attention to the other consequential effects that may happen because of that. I think that's the end of my presentation. Yes. Perhaps back to you, Titus, to say something as you take it back to the moderator.
Yes. I have Jasper. There is something he would like to contribute. Jasper, mic is on you. Jasper, you are on mute. Maybe he can contribute later. So I'd like to give back the mic back to Julius.
Yes, so thank you, Sharon and Titus. I think that was quite a very elaborate explanation of why we need regulation and also the challenges that regulation would bring. Yeah, so I think you handled it very well. Despite initial problems with technical problems that we had. So thank you so much, team. I think you also handled the question from Timothy all the way from Ghana. I think you were able to address his question. On the forum, I can't see any more questions. But I see some contributions from Jasper. I think Jasper is not able to use his mic. So I can paste his contribution to the discussion here probably. Let me just do it right away so that we know what he wanted to contribute. Yeah. That is it. That is it. So I think maybe my final comments would be that currently there is a project under Kaggle. Kaggle is one of a platform that holds data science competitions. I think currently they are running quite an interesting competition where they are trying to build a model that could distinguish between AI-generated content and content that is not AI-generated. It's an exciting competition, I think, and I think it's being funded by one of the partners, and a few other partners. There, you could check it out. It's quite interesting because it probably contributes towards this discussion of regulating AI. Let me post the link there. Check it out on Kaggle. All right. So I think in the interest of time, because I don't see any more questions. Okay. I see one question from. All right. Sorry. Thank you, Andrian, for bringing to my attention. Sharon, there is a question that goes to you from Moses Wandeme. He asks, you are talking about AI regulation in European Union and America by Biden's executive order. Where is Africa? So probably I give a minute in the interest of time. Sharon, say something about or respond to that question, please.
Thank you, Julius. Yes, I anticipated that question. The thing is, with Africa, I'm yet to have seen steps for AI regulation. The thing with AI is, remember, in order for us to use AI, we have to think about data. The concept of AI is to be able to use data, to be able to train a machine, to be able to think like a human being. So even before we get to the element of AI, it's very important, the groundwork of the issue of data, which I think is part of the reason AI would fall into the field of data science. So as far as Africa is concerned, I think we are still in the development stages even of our own AI models, which is perhaps why I think most focus on countries would be on issues to do with regulation of data. If someone was to ask me what Africa is doing with regards to artificial intelligence, I would say, particularly I could talk of Kenya. there is this WorldCoin issue that happened recently in Kenya. Fortunately, I can't go into the details, but it brought about the idea of how our data act is. So now there's very tangible steps, I think, to be able to start thinking about in the terms of protecting our data as we move forward with the models. I do think we still also have to keep in touch with the things that are happening outside, because whatever is happening in the other countries is likely to affect us whether we like it or not. ChatGPT is here in Kenya, it's affecting us in our schools, whether we like it or not. So even as they are developing, because chances are ChatGPT is being developed by a company within the West, so chances are the regulation within the West are what would affect it most. We would come up with our own regulation to be able to protect us as our nations here in Africa and the different nations that we have, but we'd also have to pay attention to follow up on what is happening there. The reason I picked the two, let me just finish with this, EU and America, I think it's because there are some of those steps have been quite loud recently, so to speak. However, there are a lot more countries. For example, Germany has its own steps to data regulation. Even before that, countries like Canada and France, they had proposed something like, let's form a global, which I think it was in the slides, I forgot to mention, a global group which is going to form a kind of artificial intelligence that covers for particular the countries that are going to join that group, so that they can start thinking of regulation as a group, so to speak, for different countries. For Africa, I think we are on the steps of trying to reach true artificial intelligence. But what I wish, if I had my voice to say to our governments, is what I would wish to tell them is, let's support the artificial intelligence models that comes up from Africa. Because notice the reason the regulations are even coming up in the areas of the West, I think it's because a lot of models have already started being in the market, and now it has given rise to the need to start regulating. I feel like if that same thing is replicated within the African content, we'll start seeing the African regulation systems also going as well. Sorry for taking up time. Julius, back to you.
Thank you so much. I think that is well addressed. Sorry for that. Yes, Brian, are you still there? 1 minute. 1 minute strictly because of time. Do you have something for us, Brian Giguna? Please go.
Yeah, just something little. Are you hearing me?
Yes, we can.
Okay. Recently, we had news of a Belgian man who died or committed suicide after having some messages with the AI chatbot. So my question is this: is this a regulation matter, or is it just a ethical matter? And another question that I have is: should we put an emphasis on regulating the AI or on sensitizing the public about the potential risk, dangers that comes or arises with using the AI? Yeah, thank you.
Wonderful question. Sharon, back to you so that we go fast. Quickly, you can handle the question.
Okay. To the second question, should the public be informed of the dangers and risks? Yes, I think, in fact, that forms part of the transparency aspect of regulation. The public should always be told that this is the AI, this is where it's come from, this is the advantages it has, and these are the disadvantages. In fact, if we could have those kinds of sessions involving people who are going to use the AI even more and more, it will put us in a better position. You can imagine people like parents who would need to, suppose, use an artificial intelligence for something for their children. You need to tell them the risks it poses so that they can be able to know whatever guards and guardrails they're going to put around that area. So that I think it's important to be within regulation, the idea of transparency, of telling even the risks, particularly the risks of regulation. I think that falls into that category. Now, the question of the example you mentioned, someone who committed suicide because of some element that was generated by not ChatGPT, but a chatbot, I think it does fall to regulation to an extent, because the problem is, I don't know exactly how they would regulate, but I think it would involve a bit of technical know-how to be able to to make sure a model that runs does not end up causing things like that. What I would I think with my limited knowledge on the field, propose doing would be, for example, before which I think I've also seen in one of the orders, either the EU or the American, before a model is set out, an artificial intelligence model is set out, a lot of testing is done. It has to go through a rigorous process before it can be let out to the public. If I'm not wrong, it's under the EU, under the high risk. So one of the things that they are checking within there is the rigorous testing of an AI model before it can be able to be given to the public, especially because those may end up having a high risk. So I think it falls under the purview of regulation. Do I know exactly what the regulators need to do in that aspect? I'm not sure. I could see a few things that maybe could help here and there, but maybe they could even introduce technical know-how within the regulation. So have someone who understands the aspects of exactly how the chatbots work and how they are gathering the information, so that we can even start putting a regulation within those small bounds. But I think anyway, I'm talking out of ignorance here. I don't know how easy that is or how difficult that is, but I do think we should regulate it in general. Sorry, Julius, back to you.
Thank you, Sharon. I think your comments brings us to the end of the session, the open forum. Yeah, that was our first topic. So we are currently now moving to the second topic. But just to remind members or the audience that we still have some ebooks courtesy of Colleen, the author. We are going to be giving at the end of the session. So keep it here as we move through the topics. So the next topic is, how is data science being used in combating climate change, and how is it being used in climate risk modeling and such? So how are we applying it in real life? Do we use it in our day-to-day, or how are organizations and governments going about the whole thing? Are they thinking of data science as a solution to this problem we have? We've heard of global warming and carbon emissions and all those climatic issues. So I think it's time we get to hear from an expert in the field. So this is kind of a presentation. You can post your chats or your questions or comments on the discussion or the Q&A or in our message inbox. So that we can post at the end of the presentation. So Colleen, I hope you are ready. So I want to give you the mic to you. Please take over, please.
Thanks. Let me see how to share.
Okay.
Can you see my screen?
Yeah, it's almost coming to my screen.
Are you able to see and hear me?
Yes, we can hear, we can see. Go ahead.
Awesome.
Okay.
So I'm going to be talking a little bit about some of the more common and more advanced methods for modeling issues related to climate change. So a little bit about me. I'm an author, a mathematician, and a tech advisor, and I'd like to just mention colleagues that have been involved in some of this research that I'm going to talk about today. So why tackle climate change? We may be in a mass extinction right now. We definitely are seeing losses of animal populations. We're looking at human displacement. Some of the projection models suggest that entire countries may not be habitable in the decades to come. We're looking at famines, increases in natural disasters in areas where we haven't seen many natural disasters. And all of these have impacts on people, animals, countries, economies, and it's really important to understand how this is going to impact the world in the decades to come. So one of the huge challenges with climate change data is the data itself. The world is huge. There's a lot of data being collected on temperatures, on weather across the world. And this complicates our analyses. One, it's huge data usually. Two, the structure of it usually is complicated. So spatial data, geography-based data, has connections over space. So what happens in, say, South Africa impacts Lesotho. And we need to take that into account, that these are not isolated systems. In addition, there are changes over time, and these are not always static. So temporal data looking across time is also very challenging. We have a lot of assumptions in our existing models that may not hold. And again, it requires a lot of computational power to account for all of these statistical correlations across time. And lately, we've been working with a lot of spatiotemporal data where we have both geographic components and time components, which makes the situation even more complicated with the structure of our data and the dependencies across time and space. So let's look at some of the traditional approaches. This includes spatial regression, so regression models that are adapted for spatial data and looking at these correlations across geographies. Within time series, we have ARIMA models and SSA models. These are pretty commonly used, but they come with a lot of assumptions about stationarity and about how these changes are happening across time, which may not hold, especially with climate change data as these problems accelerate. However, we have more advanced approaches that are being explored today, including network-based models, geometry-based models, and dynamic systems models. These are rooted deep within mathematics and provide more computationally efficient ways of modeling climate change than some of these more traditional approaches. So let's look first at climate risk modeling. This is very important within the insurance and underwriting industries to understand what the risk to property and business might be over time. So we have the actuarial approach that has been used for a very long time. Generally, this involves summing different risk scores. So for an area, we may have different scores for each disaster. So a fire hazard plus a cyclone hazard plus a drought hazard comes up with this final number of how much at risk a city is, a personal property is, a business is from these impacts over time. And this is pretty easy to do in SciPy or NumPy. And these are usually based on probability tables and event frequency estimates. So the 1 in 10,000 year flood, the 1 in 10 year earthquake type calculations. However, one of the big problems with this is climate change is impacting this. We're seeing so many more hurricanes in my area than we have in history. We're seeing stronger hurricanes than we have in recent history. And all of these probability tables are based on historical data, which is no longer accurate. And over here, a lot of insurance companies are starting to recalculate these risks based on current climate change and the projection models of what we think might happen in the future. So this is quite a problematic approach, given that it's based on historical data. We can go to more advanced models that partition our risk by geography, by multivariate clustering of types of risks, and can be based on more recent data. So a few of these more common models are partitioned regression models, where we might have a different regression model for each country, each administrative province within a country. Or we may have tree models, which partition the entire data space naively into risks that are found within the data. And a lot of these can be implemented with the Python package scikit-learn. Topology offers us a more advanced way of partitioning this data. So Morse functions are a bit like a height function over a mountain range. We define some sort of function that we can put over our data manifold. We can either have something that's univariate, just one variable, or multivariate, made up of many different variables. And this slices our data manifold into sections. More small A regression is one of the tools that I've used a bit within actuarial science that basically partitions this manifold based on whatever function is defined. This might be combined risk to natural disasters, for instance. And from this, we can find the low points and the high points on the manifold. These are technically called critical points for those of you who have had calculus. These are change points, and we can use those change points to basically slice our data into sections and then be able to fit regression models or random forest models or other risk models on these pieces of the data manifold. And we have the TopoPy package as a starting point within Python to be able to slice our data into different partitions in a more sophisticated way than some of these other more traditional approaches can do. In addition, we can also look at change points. So one of the big challenges is finding out when things are going to start changing. When are we going to start seeing these impacts of climate change? When might we expect a famine? When might we expect a drought? When might we expect things to really start changing with natural disasters in an area? Network science provides an easy way to look over time and space. So we're going to go into one of the tools that's based on the geometric notion of curvature. So basically, instead of something being flat, we have something that might have bulges in it, a bulge up, a bulge down, a bunch of bulges that might exist. And we're going to go through a little bit of that theory and how this can be applied. So there are a couple different types of curvature. There's intrinsic curvature, which is a local based approach. So we're looking at a point, say on this space down here, and how non-flat it is, basically. And this doesn't really depend on anything that we're doing with the surface. And from that, we can get a measurement of how different it is from a flat surface. Extrinsic curvature does depend on how we're processing this space. And it's basically a rate of change from something that's flat. And we can have these different types of curvature, and each has its own measurements, which are going to become relevant. So there's a type of curvature called Ricci curvature, which is a local measure of how much a space and different points in that space differ from a flat Euclidean space. And this basically measures how a shape deforms as you're moving along the space that you're looking at. And for those more technically minded, this is a symmetric measure, and it relates to the Laplacian. One of the cool things is that we can measure the change of curvature either over time or over the manifold to look at how much this is changing over time, which relates to change point detection. When the space is changing quite a bit, we can see that these multivariate relations are also changing and that our system is changing. So this is called Ricci flow, basically looking at how a manifold changes or how data changes over time. So we might start with data that looks like this and eventually see something that coalesces a bit into a more flat surface. And there are a bunch of mathematical tools that we can define to be able to track this over time. And fortunately, there's a way to turn this from a manifold into the discrete case, which is typically what we find with data. So we can do this via the Laplacian, and we can extend this notion of curvature and flow to discrete objects like graphs or networks. And this includes the measurements of Foreman-Ricci curvature and Foreman-Ricci flow, which is what I've been using lately to look at disaster data, pricing data for food, and other indicators of climate change and impacts of climate change on populations. So there's a complicated formula. I'll make the presentation available for those who want it afterwards. I'm not sure how much math everyone here knows, but there's a formula that we can use for networks. And from there, we can calculate this across time and space by slicing our data by time and looking across the spatial dimension. So basically, we can subtract curvature between time points and find the change over time, and then look at differences in different points. So in this graph, this would be a slice of time that we're looking at across a few different regions. These might be states, these might be countries, these might be cities, but we can look at how the change is impacting each area with this measurement. So basically, we can see that there's more impact and more likely to be a change in this city than there is in these cities that have smaller curvature values. I weighted these by the Foreman-Ricci curvature metric. And basically, we can use this to find when and where changes are likely happening within the environment. And this allows for planning. If there's nothing imminent, it's something that governments can make a longer term plan. But if there is something imminent, it's important to be able to act quickly to be able to ensure the safety of populations. So essentially, we can look at these changes in time and space and look for some of these large values and these large changes over time and be able to understand what's going on across time and space with any type of climate change indicator that we want to look at, whether that's temperature, rainfall, food production, disaster frequency. Any of these, we'll be able to see these changes with this tool, and it's very quick to compute to look at daily data for decades across several different regions. It's a couple of minutes to compute these models versus the spatiotemporal regression models and some of the other machine learning models that can take hours or days to compute for the same size of data. So this is really an important tool to kind of explore further as it's very computationally feasible for large sets of data. We can also look at climate change through the lens of a dynamic system. So basically, dynamic systems models look at components within a system and how they relate to each other and how they evolve over time. There's a model called the Landau-Ginzburg model, which is based on a free energy function and initial conditions and some other factors of within this paper, in particular, human-made conditions and natural conditions that looks at how the system evolves given different things that humans are doing, different things that are happening naturally, and different initial conditions. And basically, this shows the trajectory over time of how the system might evolve. One of the things that occasionally happens with real dynamic systems where things have a random component is that you get these bifurcation points where there's a system going one way or another. So with climate change, we can either get to a stable equilibrium where the planet kind of adjusts to what's going on, and one that's more of a runaway scenario where the planet kind of descends into climate chaos and it's very difficult to be able to predict future states of the system. And this is really important to understand these change points of when they occur and how they occur so that we can put policies in place to try to tip the system into more stability than chaos. There's a very deep connection of dynamic systems to topology. Topology is used to classify simulations, to find these change points, and to partition systems into the types of behavior that they exist. And again, we see Morse theory coming up, looking at these critical points within these diagrams. And we also have tools that are more traditionally associated with dynamic systems, such as this paper right here that ran these climate change models to try to understand what policies we should implement. But topology offers a great way to be able to study and classify some of these simulations that are starting to be done to understand climate change and what's impacting climate change. I'm not sure if we have time, but I can try to get a model up if that's something that we might want to do. I know that we're kind of running short on time. Maybe if we have questions, we can do that. And if there's time, I can pull up the code for an example of how to run the network science tool. Are there questions?
I can't see any, so we encourage members to post their questions, or just if you have a question, you can take the mic. I see people sharing emails. Colleen, what do you feel? How long can it take to give us the presentation? Can we have it right now? What are your thoughts?
Probably like 10 minutes.
Okay.
I have that pulled up now if we want to go into the code.
Yeah. I think you can give us an overview. You can take us through the code.
Okay. Let me share again, and I can make this available as well when we're done. So this is just going to be a quick example looking at food pricing and environmental and geopolitical impacts. So first, we want to import our packages. One of the graph packages that I like a lot is iGraph, which has a Python implementation. And then I use NumPy and Pandas a lot. So let's import those. And then the data that I'm going to look at just to show you how spatiotemporal analyses look. I have a longer one with climate change, but I think it's going to be running a little bit too long. But this data set looks at food prices over about a 10-year span, quarterly food prices across each province of Burkina Faso. So this looks at 45 different provinces and has, I think it's about 100 different time points. So we'll import our data. Because this is spatial data, we need to have spatial weights, and I created those for this presentation. And then we'll look at a time sample. So one of the things that I usually do is I'll define a correlation across this. So technically we can create something called the local Moran statistic, which is basically a spatial correlation that looks at both some sort of statistic here, a correlation, and the weights within a spatial data set. So we'll run those and then plot it. So we can see that we have a lot of correlations and a lot of connections in our graph. We'll now compute the curvature. So basically that formula, because we have just ones and zeros for our statistic, it simplifies to a very simple formula that just looks at degrees across edges within our graph. So we can define the graph, we can define this curvature on the edges, and then we can sum that up of edge curvature that attaches to a vertex to be able to get the vertex score down here. So we can do that. So that ran very, very quickly. That's almost instant running. And then we can look at this overall curvature. So we can see that the markets that are very connected over space and over pricing kind of all connect here, and that some of these are quite outliers. So these small points are outliers. And now we can look at this. I believe this one is over time and space here. So we can define different graphs for different time points. So basically, we're going to look at yearly time frames with 3/4 overlaps. So basically looking at change point across quarters here in fairly short time points. And we can run this. This code basically, instead of having one graph over the entire time range, we're breaking this up by time window, applying the same spatial statistics and calculating the same graph metrics of this edge curvature and this vertex curvature to be able to track this over time and see where some of these change points might occur. So we can run that. It may take a little bit of time. Looks like that ran. And then we can look at some plots at different time points. So this is at time point 4 right here. And we'll again look at this graph. We can see differences in curvature by the size of our vertices, and we can see that this is a disconnected graph. We have some points that are completely disconnected that have very different behavior over time and space than others, and we have some of these clusters of markets that are all interrelated. We can look at another time point, the next time point, and we can see how this changes. So we can see a bit more connectivity here, and we can see some of these have really high values of curvature, which suggests that we're seeing more change at time point 5 than we were at time point 4, indicating that the impacts of climate on food pricing seem to be going up at this time point, and there seems to be more impact in the near future. So this would be able to help Burkina Faso's government be able to provide subsidies or secure food sources or provide help to farmers who might be growing this crop locally to negate whatever impact might be coming in the next quarter or two after time period 5. We can also look at the entire vector here of the curvatures over time. And basically, this will give each time slice and each location the values. And this is something that we could feed into a different machine learning model, maybe our spatial regression model, to be able to simplify the analysis a little bit from the initial data set to something that's more of a summary statistic. So that's a little bit of how to get started with these network science tools to look at spatiotemporal data. I'll send this off so that you all are able to have this after the presentation. Do we have any questions?
Interesting. Colleen, thank you so much for the presentation. I think it's one of the most informative sessions we've had today. You really shed light into this area, and we got to see even how graph science is coming in, interconnectedness of that spatio-temporal concept. I think it came out very clearly for me and most of the members. I also thank you so much for the starter notebook that maybe you'll share to Titus so that we can share with the members of today's session. So just to remind everyone, if you'd like to receive the notebook, is a good starter, especially for those who would like to do more research in this area, and also to get the other slides from Colleen and also from Dr. Joab and also from Sharon. They did a very nice one. So please register the Google document that I've shared in the chats. So I think there's a good question addressed to you, Colleen, on the chat. It's from Bradley Okeno, and he is asking, is there an existing computer vision model that is able to isolate features from an image and assign limits to each group of weights so that they do not pass a certain threshold when retraining the model? So I think you can maybe shed some light here, Colleen.
So I don't have a lot of experience with computer vision, especially the newer models, but from a geometric perspective, yes, a lot of times something Hausdorff based was used a long time ago to isolate features. I think there are some newer ways to isolate them these days. But yes, you can assign weights and limits to each group that you've isolated. This one way to do it would be through a Morse function or something like that, or through one of these predefined thresholding methods like I did with the graph. But basically that would be a pre-processing step before something would go into like a CNN.
Great. I think I can't see any other question in the chat, but feel free. You can always post them. We can address them if you'll have time at the end. You can always post your question. For now, Titus, I feel we need to go to the last topic. Do you have any thoughts, Titus?
Yes, we can begin the final topic. We're running short of time.
Yes.
So thank you very much. This next session, we are going to first have a demonstration from Dennis. We had built some tools that analyze different asset classes. And this Colleen played a huge role in contributing to some of its development. But our data scientist will not be available for now. He has some very family matters he had to attend to. So in this case, I introduced a friend of mine. It's someone who is heavily active around using algorithms to make investment or trading decisions. And after this, we're going to have a quick chat, maybe just job and just maybe just for 5 minutes. And maybe in this case, we should be done hopefully in the next maybe by 4:30-ish. So Dennis is a trader. He is a student in actuarial science. He is building his own company around using algorithms to make investment decisions. It's called Sedan, and it's something he has been working on for quite some time. And every day is out there trying to come up with different ways, in short, quantitative models, if I can call them so. And now I'd like to give the mic to Dennis. Adrian, maybe Dennis, you can give him the chance to unmute himself and possibly share his screen. Maybe Dennis, if you can be done like 5 minutes or so, then we take questions, the better. Dennis, mic is on you.
All right, thank you so much. Titus, kindly confirm whether you can hear me.
Yes, we can hear you. Thank you.
All right, so let me also share my screen. Okay. All right, so thank you so much for that introduction, Titus. So I've known Titus for quite some time. We've done some stuff together. I can also see some of my lecturers here. Joab, Jasper, you've taught me in actuarial science. I'm in Quare in my 4th year. But again, I've been in the financial markets, mostly in Forex for about 7 years, since 2017. So I'll go straight to the point, but since maybe a majority audience are not aware about forex trading, stock trading, I'll start with a 2-minute maybe introduction about the relationship between trading and data science trading and algorithmic trading, those kinds of stuff. Then I'll show you a simple example of what we do. So I've been trading FX for about since 2017, as I said earlier. Then I found a lot of efficiency doing it the manual way. I know if you've heard about some people do it the manual way, but for me, I wanted trading models that actually have quantifiable data, so that for you to tell me a trading model works, you to have a trading system that works over the long run, then it needs to be statistically quantifiable. In this case, it needs to be able to collect market data, and you need to be able to model that particular data and turn whatever data you've collected from the markets into simple to understand models that anyone can literally use. So when it comes to algorithmic trading, there are quite a variety of different ways that you can do it. The basic one is statistical arbitrage. We have a trend following. So statistical arbitrage is where actually, for example, you buy an asset at the same time you short that particular asset. So in this case, you make money, you make a profit based on where the market goes, whether up or down, but basically you picked the right asset. Then we have trend following. So for example, for me, my systems, it's both a trend and counter trend following systems. Then we have momentum, then we have mean reversion, then we have sentiment analysis and news trading algorithms. So trading and sentiment analysis, this is where I know most of us have seen so many times Elon Musk says something about, let's say, Dogecoin, a cryptocurrency, or something about a stock, then it shoots up. So using algorithmic trading, you can build models that actually capitalize on these sentiments. Immediately they are released, it's able to identify which direction particular asset will go. Then we have something known also as high frequency trading. So in fact, for me, whatever I'm doing at the moment is just a foundational structure for diving deeper into high frequency trading, because I want to build more of a hedge fund that will provide, competitive returns in the market. Because if you look at, for example, in Kenya, the kind of investments we have, money market funds, bonds, they give an average of 10, let's say 15%. The highest that maybe it can provide it's a 20%, but they're not about to give investors something, let's say 50%, 100% per annum, or even 20%, for example, a month or something of that sort. So that's why I delved into this. So I'm using algorithms basically to find opportunities in the market based on probability. So when I'm studying price, I'm looking for probability based price action, because it's a numbers probability game. You can neither be 100% right or 100% wrong. So you need to find models that work most of the time. Then after doing that, you will now come back to something key about your risk management and your money management, that will say, now you have a model that, let's say, works 40% of the time, 50% or 60% of the time. Now, how you manage your capital in this case, and if you are using the trading algorithms to fully automate your system, then money management and risk management, that becomes one of the most key important steps. Then the next thing maybe to mention before I go to sampling and showing you some of examples of the live trades, the entire process of building these trading models. When I started, building them, I knew how to trade forex, different assets, but I did not know how to start all this. But then there are key things that I think are generally important in building any trading model. The first one is trading strategy development. This is where you go to the market, and based on your understanding of the financial market, whether it's the stock market, the forex market, or the crypto market, you are able to identify market anomalies, inefficiencies in the market. Then you may use things like technical indicators or statistical models to try and convert whatever anomaly you have identified in the financial market into an edge. So if you see a problem, an anomaly, then you understand it. You build a solution based on, let's say, statistical models. You can normally into a statistical edge. Then by doing that, you build a system, you build a strategy around that that's able to on market opportunities, and you'll be able to make money on that. Build a strategy based on strategy development. The next thing comes in what we call back testing. The reason I decided to include this specific section here is because I'll hear most of the time people who have maybe tried algorithmic trading. People say, well, if you buy a trading model, it tends to for the first 2 or 3 months, then it stops working. The main reason, based on my experience and my encounter with them, the main reason this happens is because something we call overfitting. I know if you're familiar with machine learning, deep learning, you know something about overfitting. The particular machine learning algorithm or the machine learning model provides precise data based on previous data, or provides a precision based on previous data. But when you run it on current data, the performance will be catastrophic. So most people who provide these trading tools with the intention luring clients or luring the marketplace, what they tend to do is they build these models, then they overfit. So when you come and you backtest them, you will see models which have a very, very nice historical performance, but when you run it on the live, things go south. After that, it's you go to execution, then you have to code management, and you monitor and you optimize it. Now, for optimizing, this is where again you have to go back to the overfitting. You don't want to overfit your system during the optimization phase. So, for example, for me, when we build a model, I only touch about 60% of the data that I get. Then the other 30% I let. So I'll go to chart. So for us, for Sweden, we have 2 types of trading models. The one that this code that, for example, is running on my screen is based on programming algorithm known as MetaQuote language, MQL5. It's similar to C++, but it's quite different. You need to understand functions and logics associated specifically with. So with this, what we are doing is we are building systems that will take over from the trader. So you can trade with them, but do everything on your behalf. Then we have others that we're building from known as trading using a programming language known as Python. With those, we're building some form of trading a little bit. You don't even need to know much, just need to know to open a position, things like basic calculating profits or loss. Then what we call analytical tools will be able to guide on where to buy and sell, and that's where I'm headed next. So I'll go to trading view. I had picked a few on my chart at the moment. I'm not sure, maybe some of you are with forex trading, but then this is the chart, Japanese candlesticks, the green and red stuff. So what we want to do basically, as I mentioned earlier when I was talking about various types of algorithmic trading, mine is trend and trend continuation ending. So what I want to see is, let's say we are uptrend, as we can see here. I don't want to go more technical terms, but let's say we are in an uptrend. We can see price highs and higher lows, meaning price is moving up. You can also see. So what we want to capture is when price moves, it retraces a little bit, then we want to get in the market at discounted. In this case, this is a trade that we picked here. You can see on Friday, I think, was it I'm not sure. I think it wasn't yesterday. It was like a week, Friday, 3rd November. It was a trade that we picked. Then I told her, I said, you know what? This is the entry price. This price here, market about 160.008. So that is the entry about what it. So what it does is it tells us after you buy here, you need to take where it has told you. So in this case, it's 110. Then upon doing that, it will move what we call a stop loss. In trading now, stop loss is what controls the maximum amount
Dennis, I can't hear. I don't know whether every other person can hear. I can see you are speaking. Titus, is there sound?
No, I believe we
Okay.
lost Dennis.
Okay.
Maybe Dennis, you can join in the course. Yeah.
Yes, please.
So, thank you very much, Dennis. I hope you can hear us, and I hope you can catch up. So, before he returns, the reason why this is important is that just to show you a glimpse of how data science, in this case, quantitative finance, can not only be used not just in climate change, not only in building various levels of language processors, but at the same time to also make financial decisions. Let me see if this is Dennis has communicated. Oh yeah. Okay. So that's not Dennis. Maybe he can come back later. Yes. Kirini, thank you as well. So what happens is this. When we are looking at investing in any asset class, most of the time you're not even you're not even trading with human beings. Majority of all investment decisions are done with bots. And previously, I don't know if Jasper is in this discussion and Job, and Sharon actually had to leave. We were looking at various forms of markets at some point, and in this case, heavily around the American markets. And in this case, using coming up with models that understand human behavior. Why human behavior? All asset classes obey a specific rule in price action, and this rule is purely just a reflection of human behavior. So as we are talking now about AI, this is not something new. It's something that has been there for a long time. It's only that it was given a different name at some point. But before, it was just purely statistics. I think statistics was the name back then. But I am 100% sure that Jasper has something to contribute. Jasper, are you in this discussion?
Yes, I'm
Yes.
around. Yes, I hope you can
Fantastic.
hear me clearly. Yeah, thank
Yes.
you.
May you say something around algorithmic trading?
Yes, please. Maybe I would just want to add, to what Lisa said. One, algorithmic trading is, as Titus has mentioned, is of late taking more of machine form than human form. And it has reached a point where the probabilities have been embedded in computers and all the decisions as well. So it turns out that what will differentiate one machine from the other is the speed at which the machine runs, and also the proximity of this machine to the market maker. So most of the algorithmic traders have got almost like a wall-to-wall plugin into the market makers' machines. That way, their orders are routed before the other orders within the system. So it's a game of speed as much as we look at the algorithm itself. How close is the machine to the order, the market maker, and how fast can that machine execute those transactions? So that is one thing that anyone getting into the area of algorithmic trading has to take into account. Again, then the other thing is the aspect of historical or data analysis. As much as what Dennis mentioned on probability-based trading around arbitrage, that is trying to see mispriced um, instruments and trying to make make a profit out of it before the market corrects itself. There's something we call efficient market hypothesis. That is to say that the market will always correct itself after any form of mispricing. So you see, if there is a mispricing and it takes just 2 seconds, then you have to act within the 2 seconds. If it takes 2 minutes, maybe you might have some little time to adjust a decision. But some of this mispricing, as time goes by, they are happening in milliseconds, microseconds. So you have to have a very fast machine and very small execution times. Again, one more thing around algorithmic trading or trading based on computers is that most of it heavily relies on historical data, and sometimes from those who have interacted with some of the technical analysis around capital markets, it's as if history repeats itself. That's the premise with which historical data is analyzed, and some of those patterns that we see in historical data are not necessarily based on the fundamentals of the or rather the organization or the instrument itself. So sometimes algorithmic trading might lead to panic within the market based on computer decisions rather than actual human decisions. For example, there was a time when one of the pharmaceutical companies in the US had an FDA information regarding an FDA approval on a drug that they were working on, and it seemed to have been collecting. There's an algorithm that was collecting text data from Twitter, and someone tweeted that the FDA had rejected the progression of their of their research on that particular drug, and all the algorithmic bots were able to capture that, and they were able to sell all the instruments within that particular company, and only for that to be captured as information that was false and almost created what we call a flash crash within the market. The price almost collapsed before someone noticed that this was a false information. So those are some of the issues that also stem around algorithmic trading. But as we move forward, technology is taking over at least certain elements of decision making within the society. And one of them is within the financial markets, because of first the amount of data that the capital markets churns every minute. It's too voluminous to be analyzed by human So we look at both ends, and it's an area that is worth exploring for anyone looking into implementation of data science learning and information around modeling big data. Thank you.
Yes, thank you very much, Jasper. Jasper has quite an extensive knowledge around markets and how he has been using his skills and knowledge around data science in trying to make financial decisions. Yeah, so Dennis is back, but time is really short on our side. Actually, there's somebody else. Joab. Joab, do you have something to contribute to this?
Yes, thank you very much. I just wanted to add one more thing. I think my colleague has spoken. I think when it comes to this new issue of algorithmic trading, one important strategy that was what we call the quantamental, because as a human being, you're doing quantitative analysis and fundamental analysis at the same time. I think the use of this new idea of algorithmic trading will enable us to analyze both the quantitative and the fundamental analysis when it comes to making trading decisions. How did the news, and if you do your technical analysis and the fundamental analysis, how do you make that decision faster so that you can be able to look at the mispricings of any other assets or stocks in the market, then you're able to make a leverage out of those opportunities that exist. So I strongly believe that this is the way to go, and maybe we need more training in such a so that we can able to leverage on it and make our trading much better. Thank you.
Thank you very much. I know Dennis is back now. Dennis, maybe you can give us a closing remark for like a minute or two. Dennis, I can see you have unmuted yourself, but we cannot hear you. In this case, maybe you can just say something to close the session. Then we can do a quick book giveaway. Dennis, maybe you can say something for a few minutes, just like a conclusion. Is it something worth venturing into? What skills do you need? And how can somebody start if they're into the space of data science? How can they start learning how to build different kind of trading tools? Dennis? I seem not to be able to hear Dennis at all. Maybe Julius, you can take over.
Thank you so much, Titus and team. Yeah, so I think in the last two sessions, we've gotten some hands-on practical sessions where we not only hear theoretical, but we see application of what we are saying. I like the bit about automated trading, where we, and I think we can even integrate NLP, that is sentiment analysis, part of natural language processing, in our models, probably to make them take into the perspective, the sentiment where the market is going. Remember the economic reports, how they shift the market trends and everything. So I believe if our strategies in investments and trading can include sentiment analysis, I think we can make them more robust I was reading up something about Jim Simons. Jim Simons is among some of the richest people we have in the world. He has run a very profitable hedge funds for quite some years now. He's a mathematician. I think I can post the Wikipedia link. Somebody can read up more about it. Yeah, he's known to use mathematical models and probably high frequency trading in his hedge funds, and he seems to be doing quite very well in the field. Yes, so I think the horizon is full of opportunity, and if we're able to harness data science, big data, Colin was trying to show us how we can pick up data from organized databases, from unstructured data from the internet, and try to merge them and try to build our models, with that kind of robust data. I think we can make them better and maybe improve accuracy and performance. So that was quite informative, and despite the challenges our presenter had, but we got to get the points from Titus and Jasper. So thank you so much, everyone. Yeah, so I believe we've come to the end of our presentations. And what we had today, we have already gone outside the time limit. I'm so sorry for that, but I think the discussions were worth our time, and I believe we picked up great lessons. We have remember to register again. I remind you to register in the Google Sheets that we shared earlier, just in case you want to get some of these resources that our speakers and panelists had today. From this point, I think I could, Titus, maybe just thank the speakers, the moderators, that is I, Julius, and also helped by Titus. And also thank the audience who have been very persistent throughout this time. You've remained here, you've followed us to this point. We are so grateful for that patience and perseverance. We promised to award some ebooks from our one of our presenters today, our guest speaker, Colleen. She is an author and she has an amazing book. I'm sure those who have contributed a lot, or maybe, I don't know, I think I'll give this this task to Titus to award the ebooks. I don't know whether it can be done now or later on we reach out to the people. Titus?
Yes, thank you very much.
Okay,
so this, we have books that we can share, books written by Colleen herself. I believe Colleen, she's still in the meeting. Yes, I can see you. Thank you, Colleen. And this book, we're going to distribute them. First of all, we have different GDSE leads from different parts of Africa. So we have Ghana, we have Kigali, we have Kenya. I'm looking for another country. So if I've not mentioned your country in this lineup, it would really work well. We'll also see who else we can also award. So we are going to send you a message or an email. I think that one would be better, Julius. I think that one should be better so that we can go through the chat and try to pinpoint who they are, where they're from, get their contacts, and any other active performer. We'll just go through the entire chat, and that's, I think that's pretty much it. But I've seen there's some questions, maybe one or two questions. I don't know if we can take them.
Yeah, I think we can take them as
yes,
the last.
I've seen one by Isaac. Maybe that one can be taken by Jasper. Yes, Jasper, there's a question by Isaac. What essential skills does a quant require? Since you're already doing a doctorate in quantitative finance, and which companies would be recommended for applying for a quant internship? What qualities are sought after in a quant intern? Jasper?
Okay, thank you, Titus. For the essential skills, one, as a quant, you require a mathematical background. You have to have mathematical background, both pure math, that is to say, you have to have something around algebra. You have to have something around, I think today we have been introduced on the concept of topology, manifolds. You have to have some basic mathematics on calculus, and you also need to be well abreast with the context around the instruments that you'd want to trade. First of all, the market as a whole, and then as you specialize into the specific instruments, how the whole financial ecosystem works. Again, technology is fast taking its lead in finance, so you have to have some knowledge around programming. There is this company called I think I'll text it in the group, that does a lot of internship around quantitative finance, and most of their tools are developed around Python programming. And so if you are looking into venturing into that area, you have to think towards mathematics, finance, and also computing skills. Again, this is one area that involves ton and ton of data. I don't think there's any other place that has got more data than finance itself. So if you look into that, you'll find that you'll also need some of these basic big data science tools. Again, on the areas or rather companies or areas where someone could seek internship, uh, again, most African companies are fast approaching the West sophistication in terms of implementation of some of these tools. So most financial entities around, banks, capital markets authority for as regulators. We also have most of these lenders, like the mobile lenders that are not necessarily linked to banks. There is also the central bank as an entity and so on. So any institution that has got elements of financial analysis, you'd want to try that. And then, of course, there are those that do hedge funds and mutual funds and so on. Those would also provide you with a good grasp of a basis on where to start from. The next question is, what qualities are sought after for an intern? Of course, internship in most cases is an element of learning. So just acquaint yourself with what is basically required. For example, the mathematics part of it. You might not know exactly what that institution would require from you, but you should be able to acquaint yourself with some mathematical knowledge, some programming skills, and some basic financial, for the world of finance as a whole. Thank you. Back to you, Titus.
Okay. As Titus comes in, I think I saw another question that probably we didn't address. It was about secondary data. I had seen it somewhere. I don't know whether in the Q&A. I think he's in the Q&A. Yeah. Yeah. Good. There's one from Peter Mature from Q&A section. He asks, what kind of challenges do you face when applying ML or machine learning to financial markets? I don't know who will go first. Jasper, please.
Challenges of implementation of these models. First, I think there is one theory around quantitative finance, is that they are the rocket scientists of the financial market. whenever that term is used, is to mean that whatever they do, they are the only people who know what they do, and that is a huge issue within the financial world, especially quantitative finance. As you remember, the 2008 financial market crash was deemed to have been caused by some of these actuarial models that were developed by quants. And most people to date do not understand how those mortgage-backed securities actually work, or how they came to cause the crash in the market. So one of the biggest challenges is getting to explain this to the world, because every now and again, especially for the hedge funds, you have to pick people's money and you want to explain to them how you want to put this money to use, and it becomes a huge challenge bringing down this knowledge to people outside the scope of this area or expertise. Thank you.
Okay, great. I think that's well addressed. I also see a question I think we didn't see early enough from Joshua Rwanda. I think, let me check. He is still in our chat, Joshua Rwanda. He had asked, and I think he had addressed the question to Colleen. How has graph theory, Colleen, thank you so much for your patience. I still see you in the meeting, so probably you can take this one. How has graph theory and network analysis influenced the title of your book?
It influenced it a lot. I was in graduate school when I encountered network science, and it's been interesting throughout my career to see the interplay of setting up problems either as more of a traditional data science approach or as more of a network science approach. Network science has deep connections to geometry and topology, which is my area of mathematics. And I think we'll be seeing a lot in the coming years as big data requires more computationally efficient solutions. I think we'll see a lot more of network science. I'm working on a second book right now that focuses solely on network science within the field of data science and how it can be used to really wrangle these different types of data and solve a lot of real world problems.
Wonderful. So I think that is also very well handled. We have another one. This was quite early earlier on from Adrian Etenyi. He was asking about, with this new OpenAI update, which introduces GPTs, what does the future of software engineering look like? A shift to prompt engineering, maybe? So I don't know who goes first from our panelists and the speakers. Yeah, you can go, please.
I can take it, or I can get this started. One thing that I've seen in industry, especially within machine learning, engineering, and data science, is a shift towards prompt engineering. I don't think it will replace software engineering or data science, but I think it's going to be one of those tool sets, kind of like how a lot of positions required deep learning a few years ago as those models kind of came into vogue in industry. So I think we'll see a lot more with prompt engineering and generative AI tools as another set of tools that data scientists and software engineers can draw upon.
Okay, great. All right. So I think we have addressed all the questions so far in the chats, unless there is any that I'm leaving out, probably it can be pointed out very fast before we end our meeting. Okay, just a second or two. Okay, so I don't think, I think we have addressed all our questions. So that brings us to the end of our talk today. I want to believe that it was informative. or from all the three topics, I also believe that our audience have been able to pick a few things here and there in matters climate modeling, in matters application of data science in finance, in matters about NLP, AI regulation. I believe we've all we have a lot to digest. We have a lot to think about these areas, and the materials that are going to be shared later through the emails, I believe they're also going to help us along the journey. Thank you once again to our speakers. Feel much appreciated, Colleen, Dr. Joab, and the whole team from Candlestick Investments. We appreciate your time and presentations. Thank you so much also, Colleen, for the books. And we are going, I believe those people who are selected to or will be get the books, I believe they are going to make very good use of them. And yeah, probably you can always give feedback to Colleen's through LinkedIn. I believe she shared already her profile, her LinkedIn profile earlier. If you go through the chats early on, so you can always engage her and also Dr. Joab and the rest of the team later on. Yeah, so I think it was a nice session, and you've also got to network. You have at least added one more follower, or you have followed one more worthy profile on the LinkedIn or Twitter. Yeah, and I believe the collaboration goes on. Yeah, so without further extending the session, I want to bring the talk to an end and thank everybody. Meet you next. Goodbye, everybody. Thank you. Unless there are final thoughts, final comments, as people are free to leave now.
Yes, just to say thank you to everyone. This was an amazing session. I've been asked if there is a WhatsApp group. Sadly, we do not have a WhatsApp group. This is one of those one-time events that we hold. But we are definitely going to hold another one. We are going to hold one around health. So we're going to see how AI and data science is being used around health. We're going to go into deeper with, apparently Dennis could not be able to take us through everything. We'll definitely hold another totally separate event around finance. And over time, based on what people are interested, we're going to hold sessions on those. At the same time, check out what we do. Check out Colleen, check out Candlesticks, check out Julius, Joab, Jasper, Sharon, Cleo, Fidel, Adrian, Brian Juguna. So it's a huge team. So feel free to check us out on LinkedIn. Candlesticks Investments is a group of companies, and the reason why we held this session today is that we are heavily AI driven. So we have tools that are literally built on some very complex models that only our data scientist team can understand. For us, we know it works and we're happy. So we'll be holding slowly one event at a time to tackle each and every single sector that we can. So I'd like to give a vote of thanks to everyone who was able to stay with us until now. A vote of thanks to the panelists, to the guests who are able to make this happen. We'll be reaching out to some, we don't have a lot of books, we are limited, but based on what we're able to get, thank you, Colleen, for having this possible. We're going to distribute them based on specific criterias. So we'll be reaching out to you, we'll be communicating with you, we have your email addresses. And thank you very much. I hope you've learned a lot. Feel free to be on the lookout for our next events. We were challenged to hold a physical one. So we are going to see how we are going to pull off a physical event. The quorum is there, the knowledge is there, people are willing to share. So that's it. Thank you very much from my end. Maybe Colleen, you can give us a closing remark as well.
Thanks so much, everyone, for attending. I hope you got a lot out of this, and please feel free to contact me on LinkedIn if you have any questions or ideas. I'm happy to connect with all of you.
Yes, on behalf of everyone, goodbye. Have a wonderful event, and let's go out there and build solutions. Goodbye.